My name is David Brown. I'm with the Energy Conservation Institute, and I'm standing here today in front of one of our recently completed mobile training labs. Now, this particular lab was built for Northeast Community College, and more specifically for their HVAC and weatherization program. This lab is 24 feet long by 8.5 feet wide by approximately 12 feet high, and we've custom built this laboratory to their specifications from the chassis up. Now, we can build labs in any size, from 12 feet to 53 feet, based on the configuration that our clients need. Now, the purpose of this video today is to go over some of the features and functions of the lab, as well as to discuss some of the safety precautions we're going to want to take before we use the lab each time. So to start with, we have an electric tongue jack. Now, this tongue jack is designed to help raise and lower the lab when you're connecting it to the tow vehicle. It's also used to help us level the lab from front to rear. In addition to the tongue jack, we have a jack mounted on each corner. Now, these are manual jacks where you pull the pin out, lower the foot, and then use this adjustment nut to raise and lower each corner of the lab. Now, remember, it's always a good idea to start off by parking your lab on a flat and level surface, and then just use the powered and mechanical jacks to get a little better leveling and to make sure the lab's nice and stable before use. You'll also notice at the front of the lab we have our 2 propane tanks. Each one of these propane tanks will hold about 25 gallons of propane, which is quite a bit of propane for powering both the generator and the furnaces on the inside. Now, when one of these tanks runs empty, you have a switch up here on the valve that will allow you to automatically switch over to the other one just by turning the knob here. And also mounted on this valve is our pressure control system, which keeps the propane pressure going to the generator and to the appliances at the manufacturer's recommended level. You also have a 7.5 kilowatt propane powered generator. There's a locking cage on the front here just for security, but to access the controls for the generator, you just remove this door here. And inside you'll find the main breaker to the generator, a start button, a prime button, and also a fuse for the ignition system. This is also where you'll fill the oil and do your service on the generator. Just be sure to check with the manufacturer's manual that's included to make sure that you keep your servicing up to date. Now, there's also a remote start button located on the inside of the lab that I'll show you in a minute. So when you go to start the generator, you'll just do it from the inside of the lab. This is a 1.5 ton condenser that's connected to the split system HVAC system on the inside. In the back you have your refrigeration lines and your electrical connections. These are great to show students during training how to properly install the condenser. You also have a 30 amp disconnect right here. This is just a standard panel for disconnect. You just remove this part right here to kill power to the condensing unit. Now let's take a look at the driver's side of the lab. Okay, so now we're on the driver's side of the lab. The first thing I want to show you is what's stored inside this storage compartment here. Inside you're going to find the 200 amp main panel. This is the electrical panel that controls all the lights, receptacles, and appliances inside the lab. Beyond the electrical panel, there is a small box that has the switching relays. Those relays will allow you to switch from shore power to generator power without having to make any changes. You'll also notice there's a large 50 amp cord inside of here and adapters that allow you to connect to 30 amp and 20 amp receptacle as well. This cord's used if you're able to hook the lab up to regular shore power or building power. Now, I want to point out that if you're going to be running the air conditioning system, you will need a 50 amp 240 connection. If you're not able to plug this into a 50 amp receptacle, you'll need to power the generator in order to use the air conditioning system. Now, also in the back of this storage compartment is a 12 volt battery. That battery is used to start the generator and also to power the electric tongue jack that I showed you earlier. There's also a built-in 12 volt charger that's powered anytime you run the generator, or again when you plug this cord into shore power, and that'll keep the battery charged for you. Now, the other thing you'll notice on the driver's side are the 4 flues that go through the roof up top here, and those are connected to the furnaces inside the lab. One thing I want to point out to you is that if you have conditions where you're not able to achieve proper draft in the furnace, you are able to go up through the roof ports located in the attic, which I'll point out to you in just a little bit, remove the rain cap from the vents and actually extend those caps. So again, when we test these labs before they leave, they're all drafting properly, but you may have conditions that warrant you extending those vents, and that's how we do that up there. Now, the last thing I want to point out are these 3 doors on the side of the lab. We call these our supply dump doors, and the purpose of these doors is to exhaust the conditioned air that the furnaces generate to the outside. Now, they work in conjunction with the return dump doors that are located inside the lab underneath the furnaces, and I'll show you those in just a moment. Now, it's important to note that only one furnace inside this lab is connected to ductwork. The other furnaces operate just by using the supply dump door and the return dump door. So it's important to make sure that you have both those doors open when operating those furnaces so that you can move the conditioned air through the furnace into the outside. Now, this last door is connected to the furnace and air conditioning system that actually heats and cools the lab. And this door, you'll see, is configured a little bit differently. This door we allow you to adjust. There's actually a thumb screw up inside there on a bracket that allows you to adjust how much you open and close this door. Now, if you want to keep all the heated air or cooled air that you generate inside the lab, obviously you'd keep this door closed. But if you want to simulate a leak in the duct system, the supply side, you'll come out here and adjust this door accordingly. The same would apply with the return side. If you want to simulate a return leak, as you typically find in a residential system, you'll be able to adjust the return dump door underneath that furnace inside. So again, if you're operating the first couple furnaces here that are not connected to the ductwork inside the lab, you'll completely open the supply dump door and the return dump door so the systems actually work as a closed loop with the outside. When you're testing the heating and cooling system that actually condition the lab, you'll have the option of adjusting this door to simulate the supply or return leakage. Now let's go take a look at the back of the lab. Okay, so here we are at the rear of the trailer. Now this particular trailer was built with a ramp door. It's very easy to operate. We just want to unlatch it. And this is a spring-loaded door, so although it'll hold 2,500 pounds, it's pretty easy just to raise and lower. Now you see we've built a standard exterior wall here. This has vinyl siding, it has a receptacle, a porch light, and up inside here we even have gutters and downspouts. We built this so students would understand that there's a need to inspect the exterior cladding system and components, as well as all the interior thoughts that we have. Now, one thing I'll point out about the gutter system is on this side you'll notice we have a downspout basically properly installed, and on this side it's missing. So that's one of the things we want the students to pick up on during their exterior inspection. You'll also notice we have a standard size front entry door. This is a 32-inch wide door, and this is also where we're going to install the blower door once we go inside the lab. So now let's go ahead and take a look at the passenger side of the lab. So here we are on the passenger side of the lab, and just a couple things to point out here. First of all, we have a very large viewing window that's operable from the inside. As we come down here to the lab, we have a nice handle to help you enter and exit the lab. There's a double set of fold-out stairs that operate like so. And then there's a door latch to keep the front door open. Also on the front we have a storage cabinet, which is located here. And inside here you'll find the jack that can be used to raise and lower the mechanical jacks on each corner. This is also the water spigot or water fill valve for the water tank inside. And it's also the valve that we use to get rid of the hot water out of the heater. So if you're testing the water heater and you end up heating up the water to where it will not fire anymore, you just open this valve here and you're able to release the water out. It's also a good idea to keep this valve open when you're filling the tank. That way you don't inadvertently overfill your water tank. Now let's go inside the lab and take a look at some of the features inside. Okay, so now we're inside the lab, and I'm going to point out a couple of the features inside the main body of the lab before we move on. So earlier I mentioned there's a remote start for the generator, and the switch is located right here just as you enter the main door. So to start the generator, you'll first hold down the prime button for about 5 seconds, and then hold the run button down for about 3 seconds until the generator starts. You can also stop the generator from here as well. You'll also notice that there's a small hour gauge here that keeps track of how many hours the generator's been used so that you'll know when to service the generator. Also down here below the generator switch is the first of many air leakage ports that we have throughout the lab. And these ports are great for adjusting how much air leakage the lab has. So when you're doing blower door testing or even combustion testing, you can use these ports to bring more air into a specific room or area. So this is the first one located down here on the floor. And then right above me is one that's connected to the attic above. And all you need to do is twist them to open them up. And again, you'll be able to create leakage from outside through the main body or each one of these rooms and up through the attic. And there's about a dozen of these located throughout the lab. You'll also notice that mounted by the door is a carbon monoxide alarm. Whenever you're using the lab, you want to make sure that you have not just this alarm working, but preferably a handheld carbon monoxide alarm as well. Because we can generate so much CO and we can put this lab under different pressure scenarios, especially negative pressures, we want to make sure that we don't have excessive carbon monoxide. You also see above the carbon monoxide alarm is the first of 2 LCD monitors we have. These are 32-inch LCD monitors, and you'll be able to connect your laptop or other video device to these monitors at a station we have over in the kitchen area that I'll show you later. Now we're going to take a look at our laundry room. And this laundry room is very typical to the laundry room you'd find in a residential home. And the first thing I want you to notice is that we have a nice viewing window here so that while you're teaching students how to test the water tank, everybody else in the lab will be able to see. So that's the reason why we've done a nice viewing window and also a glass door here. So this is the laundry room, but it's also our first pressure test room because we've got a lot of variables in there that will help you illustrate different scenarios. And it's also our first CAS area, or combustion appliance zone, due to the fact that we have the gas-fired water heater in here. So let's go inside and we'll take a look at some of the other features we have. So on this side of the laundry room, we have a traditional gas-fired water heater. This again runs on propane like all of our other appliances in here. And this is a traditional water heater that you'd find in the average residential home. We're using a 3-inch B vent here, which passes through the attic space and then out through the roof line. You'll see we've got a hole already drilled in the flue pipe here for you to do draft testing. And if you like, you can drill holes here in your diverter to measure CO down in the throat. You'll also see that we've got an adjustable speed exhaust fan here. This is great because you can adjust the exhaust from 50 CFM approximately to 110 CFM, and the exhaust fan is located right here above the water heater, so it's great for showing how going with too much negative pressure can affect your draft. You'll also notice up here just to the right of your exhaust fan is one of the leakage ports that I showed earlier. So if we want to create a leak in this room through the attic space, we would simply remove that port. Now let's take a look at the other side of the laundry room. Okay, so on this side of the laundry room we again have one of our leakage ports. Remember, you just turn these to open them up, and this will now create a leak from the outside into this room. Also on this side of the laundry room we have a typical clothing dryer. These are great to illustrate to students how much exhaust power a clothing dryer can have, especially in a small space like a laundry room. Now this is a gas-fired clothing dryer, however the gas is not hooked up. We only need the motor to run to illustrate the exhaust portion of the dryer. And above the dryer you'll see we have a supply grill, and that has an adjustable grill on it. So this grill is connected to the ductwork that runs throughout the lab and is connected to the 80% heater and also the air conditioning system. So this is used to heat and cool the lab, And again, because it's adjustable, you can determine how much airflow you want. And again, the idea of this room is to allow you to manipulate the environment to create any number of scenarios. And the last thing in this laundry room is the operable window to the outside. So again, this helps in illustrating the different scenarios you want to set up, plus when you go to do blower door testing or worst case combustion testing, you want to make sure that students are aware of this window and that they close it before testing. Okay, so now we're going to look at the first of two pressure testing rooms we have. Now these are in addition to the laundry room. And what these pressure test rooms are used for is for you to simulate either a bedroom or a bathroom that you'd find in a residential home. And we've got various equipment in there that's going to help you change the pressure to whatever suits the scenario you're trying to teach. So before we go into the room, I want to show you that we have jumper ducts installed above each one of the pressure test rooms, as well as the laundry room. And these have adjustable grills on them, so you can adjust the pressure, relief pressure, from each one of the pressure test rooms back to the main body. Because the supply air creates quite a bit of pressure in this room, we wanted to give you a way to relieve that, plus show students the benefits of installing jumper ducts. So inside the room, we've got equipment similar to that we showed you inside the laundry room. So down on the floor, you'll notice that we have a leakage port that goes to the outside. So again, you'll use this to create a leakage scenario that you would typically find in a home due to cracks in the foundation, in the walls, plumbing, and other issues. We've also got a leakage port to the attic, again, just helping to relieve pressure in this room and create leakage scenarios. Up in the ceiling, we also have a supply grill that's connected to the ductwork throughout the lab, so you decide how much supply air you want by just adjusting the grill itself. And then there's also an operable window to the outside. So with all this different equipment in here, you can decide if you want to operate this as a bedroom or a bathroom, and if you want it to be a positive pressure or negative pressure. One unique thing about this room that we'll also see in the next pressure test room is we have an adjustable valve down here that's connected to the return plenum of the 80% furnace. And again, this is just another tool that's going to allow you to have complete control over the pressure that this room creates. You can either make this room extremely positive or extremely negative depending on how you set it up. And remember, in regards to the window, you want to make sure that you point these out to students so when they go to set up for worst case or for blower door testing, they make sure that they close that window as needed. So let's go and take a look at our furnace platform now. Alright, now we're going to look at the furnace platform. And you'll see this platform is built to house 3 different furnace types. So in this particular lab, the first location has been left open for the client to install whatever type of system they like once they get the lab delivered. In most cases, we recommend finding an older furnace from the local housing stock that best illustrates what a student will find once they enter the field. You'll see we've already installed the gas line and the electrical connection, as well as a connection for the supply dump door that we talked about earlier. Now you'll remember when I talked about the supply dump doors earlier, I mentioned that they work in conjunction with the return dump door. So when we operate a furnace on the furnace platform here, we want to make sure we get all the conditioned air exhausted to the outside. So we accomplish that by opening up the supply dump door from the outside and then opening up the return dump door, which is located down here behind this grill. You just open up the door like this, and now the furnace is basically connected to the outside, so it'll draw its return air primarily from outside and exhaust the conditioned air through the supply dump door to the outside. Now this is a typical wall furnace, and since it generates its heat from the front of the unit, there is no way for us to exhaust the conditioned air. So when you test this unit, unfortunately you will be getting the heated air brought into the lab. Now, this particular unit is traditionally installed as you'd find it in a home, in between a 2x4, in between a 16-inch bay. And it's got a 4-inch B-vent, which passes through the attic space and out through the roof line. And there has been a hole's been drilled in the vent pipe 12 inches above into the attic. So if you want to test draft in this unit, you'll be able to do that from the attic. And behind this unit, we've left the wall open. Inside there are plumbing and electrical connections that would be typical to what you'd find in a standard home. So the holes have been over-drilled, they're oversized. And we put this in here so students would have something to inspect and to talk about in regards to proper air sealing. There's also some insulation installed on the opposite wall that's been done improperly. Again, we've put that in there just so students have something to go over with the instructor in regards to how they would properly insulate that wall and how they would properly air seal it. The next unit on our furnace platform is a high efficiency condensing unit. You'll notice we use clear PVC 40 piping here so that when this unit is operating, you can actually see the condensation happen down this pipe. And typically you'd have these panels removed so that you can show how a sealed combustion unit works, as well as the different controls in the blower. This unit also has its own return dump door, which again works in conjunction with the supply dump door. So you just open this up down here completely when you're operating this furnace. It's important to remember that when operating either this furnace or this furnace, that both the supply and the return doors are completely open. If you only open up the return or the supply, you will end up creating a rather large pressure difference in the lab, and you could also cause some harm to the unit. So make sure that when testing these units, both the supply and the return dumps are open. Now we're going to take a look at our last furnace, which is the 80% unit, which heats and cools the lab and is also our second CAS area. And inside here, you'll see that we have an 80% fan-induced furnace with the AC coil mounted on top. We've also got an adjustable TXV valve so you can play with the refrigerant charge. We've got a sight glass so you can show students how the refrigerant changes from a liquid to a gas. And we've got a couple K-type thermocouples up here so you can change your superheat and subcool and measure that accordingly. And then there's also holes drilled in the casing here so that you can check your static pressures in the ductwork. So again, this is a traditional 80% unit. This is the unit that also heats and cools the lab. So you'll see when we go up into the attic, this plenum punches through the ceiling here, and it's connected to about 75, 80 feet worth of ductwork. So this will supply the heated and cooled air throughout the lab. Now earlier outside I mentioned to you that this one also has a supply dump door attached to it. And we're going to use that supply dump door when we don't want the heated air or the cooled air to come inside the lab, or if we want to illustrate supply leakage to the outside. And just like the other two furnaces that have the return dump door, this one also has a return dump door. Now the difference on this return dump door compared to the other two is this one can be adjusted. So you open up the door and you turn the little knob here mounted on the arm. And the reason this one is adjustable is because you may want to use this system to illustrate the impact of a return plenum leak. In other words, if you want to make the lab go positive because of a return leak, you just open this door and adjust it until you get the pressure that you want. The same could be said for making the lab go negative with the supply dump door. You close your return dump door down here, you open the supply dump door to the outside and make your lab go negative due to the supply leak. And this is just one of the ways that we can illustrate supply leakage in the lab. Now we're going to take a look at the third and final pressure testing room. Now just like the other pressure testing room, you can set this up to act like a bedroom or a bathroom, and there are going to be the same variables in here that will allow you to decide whether or not you want this room to be positive or negative. So as a recap, inside the pressure testing rooms you're going to find the adjustable speed exhaust fan, and each exhaust fan inside the lab is exhausted completely to the outside. And they are adjustable from about 50 to 110 CFM, so they'll make a pretty strong impact on this room as far as making it go negative. On the floor, you'll find a leakage port to the outside, and you'll also find another one of these adjustable ports, like we saw in the other pressure test room, and this again is connected right to the return plenum. So we utilize this to make the room go extremely negative, just again to create a specific scenario. Now up in the ceiling, we're going to have an exhaust port or leakage port that goes to the attic. We're going to have another supply grill that's connected to our 80% unit, and that has an adjustable grill on it so you can decide how much airflow you want. And then we have an operable window in here to the outside. The last thing you'll notice is that there is a jumper grill in this room as well, and you can adjust this again to decide how much of that positive pressure from the duct system you want to release back into the main body. So remember, these rooms are great for creating different pressure scenarios, whether you want it to go positive or negative, if you want it to act like a bathroom with an exhaust fan or a bathroom with an exhaust fan and an operable window, one where the homeowner might open up the window sometime and use the exhaust fan, or close the window and use the exhaust fan. There's a lot of variables that you can change in here so you can create different scenarios for the student. The last thing I'll point out in this pressure test room is typically we'll drill a hole right here beneath the lock where we install a manometer tube. And we recommend that you do this so that you can easily test the pressure from inside that space to out here. Since there's nowhere to stick a probe through these doors, they're rather sealed. So just drill a small hole, stick a manometer tube all the way through, and then you're able to easily test the pressure across the space. Now we'll take a look at the kitchen area. Now in the kitchen area is where you'll find the thermostats that control the furnaces. And there are four thermostats, one for each furnace. And these are just basic digital thermostats, simple to operate. Down below the thermostats, you'll find another one of those leakage ports that goes to the outside. And just as a point of reference, there's a total of about 12 leakage ports in either the floor or the ceiling throughout the lab. So again, use these ports to adjust how much leakage you have in the main body or each individual room. These are great when you're doing blower door testing because you can remove one or two different ports and show how that affects the amount of air leakage throughout the entire lab. The other thing you'll want to look at here in the kitchen is that we have a standard range hood. This is a 2-speed range hood. And what's unique about this is we've installed the vent that goes up through the ceiling and into the attic, but it doesn't vent through the roof. So it's just left open in the attic. And this is a construction defect that we want students to pick up on, that this is just venting to the attic. The other thing you want to notice about this is we've installed these cabinets on a soffit, a drop-down soffit, which is again very typical in residential construction. Now when you go in the attic space, there's a piece of duct running over that soffit that I'll show you in a minute. And we want students to pick up on the fact that the soffit has been left uninsulated. These are usually, if insulated at all, very poorly. So again, this is something students should pick up on. So the exhaust fan works properly, but it vents up and into the soffit area and stops there, and the soffit is uninsulated. Again, two defects we want the student to pick up on while doing their inspection. You'll also see we have a standard range and oven here. This has been converted to propane, just like our furnaces and our water heater. And this is ideal for testing for carbon monoxide. So you'll operate this just like you would any residential stove and oven, and great for students to see the impact of having an improperly tuned burner. You can go down inside this oven area and adjust the air-fuel mixture and have a negative impact on the carbon monoxide. Now it is set up to operate properly right now, but just by checking in the owner's manual, you'll see how you can make a couple adjustments to make this thing produce more than normal CO. Now you do want to note that if you make any adjustments to any of the gas burning appliances in here so that they burn improperly to create CO, make sure you're wearing that portable CO monitor and that the battery in the CO detector by the front door is always fresh and operating. We don't want to create an unsafe environment in here. And when you're done making those adjustments and showing that scenario, make sure to set everything back to the manufacturer's spec. The last thing I'm going to show in the kitchen is the connection ports here that work with the LCD monitors. There's two 32-inch LCD monitors, one that's in front of me and one that's further down by the front door that I showed earlier. So you can set your laptop up here, you can plug in with a VGA and a standard audio cable, or with an HDMI cable. And whatever you show or whatever you plug into here is going to show on both of the monitors. So this is great for showing presentations or displaying standards of practice or a PowerPoint presentation, anything that you'd find useful during your training. You'll also see down below there's another one of those exhaust ports to the outside or leakage ports to the outside. We've got two positioned right here by this back door because we use this door to set up the blower door. Once you lower the ramp, this makes a great area to have students practice setting up the frame and the fan itself and then running through a standard blower door test. And remember, that exterior wall has some leakage in it, so once the blower door is running, you can have students go on the outside with smoke or another test instrument and actually see some of the leakage. Now, if you just want to do some blower door setup testing, you can also use the main front door of the lab. it's suitable for setting up the frame and setting up the fan, and again, just having students go through that process of setting up and tearing down the blower door. Now we can go and take a look at the attic space. The attic space is accessed through a standard pull-down ladder. So let's go up and take a look. Now the first thing we want to take a look at up here in the attic area is we've got a couple switchers down here at the back of the lab that are for the video system. Remember earlier I said when you plug your PC into the HDMI or the VGA connectors down there, they're going to route that to both the video monitors, and those two boxes are what allow that to happen. Now this attic space is unique in that it has quite a bit of ductwork in it. Remember, the ductwork is installed with the 80% furnace down there that heats and cools the lab. So the first thing I'm going to show you, which you don't see very often ever in an attic, is a supply grill, supply register. And we've got two of these up here. And they serve two different purposes. So the first is they will help heat and cool the lab when you're up here using it for instruction. And they also help us relieve static pressure. Because this is such a small area for a full-size furnace and air conditioning system, we use these two supplies up here to help us relieve the overall static pressure. It's also great to illustrate air leakage, supply leakage, because if we open these grills up and open up the roof port above me here, which I'll show you more in a minute, we can actually create a nice supply leak. So remember earlier I showed you the supply dump doors that you can adjust for that 80% furnace. That's one way that you can do a supply leak, and then utilizing these is another way. So a couple things we want to show students in here. I'm going to go towards the back more. Earlier I talked to you about that soffit area in the kitchen. That's right underneath this ductwork here. And so that soffit's been left uninsulated. We want students to pick up on that. And then we also have that exhaust range hood grill, or I'm sorry, exhaust range hood that has been left just open in the attic here. It should be going through the roof, and that's again something students should pick up on. Another thing they will need to see is that we have can lights that are leaking to the main body, and although the can itself is insulated, it's still a leakage source from the main body up through the attic space. You'll also notice up here that we have a couple different insulations on the duct. We have some at R8 and other at 4.2, so that's something else we'd want a student to pick up on. There's also some things like a TY installed backwards here. That's another deficiency that's great to point out to students. And as we move on through the lab up here in the attic space, you're going to see we have our exhaust fans. Now all the exhaust fans use a remote motor that are in front of me. I'll show you in a minute. So this is actually just the grill and the collector box for it, and then the ductwork all goes up towards the front of the lab to where the motors are. So we'll show you that in just a second. And then you'll see all your flue pipes are mounted here too. So you've got the 4-inch B vent that's connected to the 80%. You've got the PVC pipe there that's connected to your high efficiency unit. And then past the PVC pipe we have another 4-inch B vent that's connected to the wall furnace. And then you'll notice that last vent down there that's installed on top of the plywood box. That last vent that's installed on the plywood box there is a 5-inch vent that has been pre-installed based on the customer's needs. They're going to be installing a furnace once this lab gets to their location that uses a 5-inch B vent. So we went ahead and routed that B vent for them out through the roof and flashed it properly, so all they have to do is come in, install the furnace, and hook up the venting. And then, as I mentioned earlier, there's those 3 fans that are mounted, the motors mounted at the front of the lab. And those are fan techs. And you saw earlier those are adjustable, so those will go from anywhere from about 50 to 110 CFM. You'll also notice that the attic is adequately lit and that we have this plywood catwalk here. So this is great for bringing multiple students up here, although I wouldn't recommend bringing more than about 3 total bodies at a time. And this way you're able to show students a typical attic space. And although we've insulated everything in here, there are a couple deficiencies you want to point out. One other thing I'm going to show you in the ductwork right here is we've got a damper on here. And this is an adjustable damper, and the reason this is here is so that you can do static pressure testing and control your static pressure. As I mentioned earlier, in that 80% unit, we have holes drilled in there in the box itself so that you can measure static pressures. And by opening and closing that damper there, you can greatly impact the static pressures. Now, earlier when we were outside on the driver's side of the lab, I talked to you about the venting for the furnaces, and I mentioned that it may be necessary sometimes for you to extend those vents if you're unable to get the furnaces to draft properly. And so the way that you access the roof is through these ports here. And basically, if you flip this little red lever forward, you can open up the port and go out on top of the roof. Now, we've set 2 ports in the attic. One is here, and the other one is in front of me. And they're set appropriately up here so that you can actually access the vents without having to step out onto the roof. We do not recommend you go out onto the roof unless you have some sort of safety harness to protect you from falling off. So again, these are positioned accordingly so that you should be able to get up there and extend the vents when necessary. Also, as I mentioned earlier, we've tested all the gas burning appliances, and at the time of building the lab, everything tested properly. So you should be able to get all your appliances to draft properly. But again, if you want to make adjustments to the vent pipe length, you can do so through here. Now, these ports, these roof hatches, actually operate 2 ways. The other way is that you have an adjustment here, so you can open this up and make the attic vented. So you can illustrate a vented attic space. So when we open up these supply grills here and we open up the vents to the attic space, we can actually create a nice leaky attic with a lot of supply loss through the duct system. Okay, so let's go back down to the main body. Alright, so this finalizes our introductory video to the mobile training lab. Hopefully this video helps you better understand some of the features and functions we've incorporated into this lab, and also the ways that you can adjust the different systems to create the scenarios that you find best for teaching your students. If you have any questions about using the lab, please feel free to call our office at 805-644-2877, or you can visit us online at energyconservationinstitute.com. As a last reminder, you need to remember that this lab has some health and safety concerns that you always want to be aware of. Number one, remember that you have combustible gas running throughout here. Propane is very combustible, so you're going to want to constantly be checking your gas lines and fittings to make sure that you don't have any gas leaks. And then remember the carbon monoxide. You have the one alarm here, but you should always have a safety monitor operating as a backup anytime you're utilizing the lab. And last, because you can go create such negative pressures inside the lab, you always want to make sure that you're monitoring just how negative that pressure is from the main body to outside, especially when you're operating your furnaces and other combustion appliances. Remember, the health and safety of your students is most important. Thank you very much for joining us here today, and we look forward to working with you again in the near future.